Hi, I'm Umi. I will proceed to process description. Okay, firstly, our raw material used is 50 kg per day, and then we convert it into 2083.33 kg per hour. Okay, so this amount of sugar beet will go into the slicer where we slice them into small pieces, and then it goes to the extractor. Here we put hot water so we can extract the sucrose from the small pieces. Okay, then we go to the purificator. Here liming process occur, which we use carbon dioxide and calcium oxide for the liming process, and then we went to the filter to get rid of the lime cake and some impurities, and then lastly we went to the evaporator. Here we remove some water so we can get the tinges. So our last product is 370.65 kg sugar per hour.
Hi, I'm Shweta, and then I'm going to proceed to the process selection route. Then, firstly we use slicer unit and then extractor unit, and proceed to the purification unit. In this purification unit, we have involved two process, which is carbonation and also liming process. And then we proceed on the filter, and then lastly is evaporator. Thank you. And this is our completed PFD that consists of temperature, heater, and pump, and so on. So the first unit we use is slicer. We put 2083.33 kg per hour as our feed from the beet. And then we have two stream output, which M.2, which is 1874.997 kg per hour that contains sucrose, water, and impurities. For the M.3 stream, we have 208.33 kg per hour that only consists of impurities. Okay, next is extractor unit. We have 4 stream. For M.2 is come out from the slicer unit, which is 1874.997 kg per hour that contains sucrose, water, and impurities. In the extractor unit, we add water at 70 Celsius, and the flow rate is 937.4985 kg water per hour. And then we have two output stream, which is M.6. The flow rate is 2757.35 kg per hour that contains sucrose, water, and impurities. And also for the M.5 stream, the flow rate is 55.15 kg per hour that contains sucrose, water, and impurities. So I proceed on the purificator unit. So we have 4 stream. Firstly, M.6 we get it from extractor unit, which is 2757 and 57.35 kg per hour that consists sucrose, water, and impurities. And then we proceed on the M7. We put M.7, which is carbon dioxide, to process the carbonation process. We use it 0.04 kg carbon dioxide per hour. And then for the M.9, we get calcium hydroxide from the reaction reaction of calcium oxide and also H2O, which is we use 68.93 kg calcium oxide, and then react with H2O, and then we get 91.08 kg carbon hydroxide per hour. And then from M.10 and M.8 we react, and then we get M.11, which is 2848.47 kg per hour that contain of sucrose, water, and impurities. Then I proceed on the filter unit. In the filter unit, we trying to remove as much as we want. We try to remove many impurities. And M.11 we get it from the purification, which is 2848.47 kg per hour, that contains sucrose, water, impurities. And then we have two output stream, which M.13 we have the fluoride 2705.48 kg per hour, that consists of sucrose and water. And then for M.12 is only impurities that come out, which is 142.99 kg impurities per hour. Then lastly is evaporator unit. In the evaporator unit we have M.13 that come out from the filter unit, which is 2705.48 kg per hour, that consists sucrose and water, and also we use to heat it at 80 Celsius, at temperature 80 Celsius. And then we have we also put M.16, which is steam, with the flow rate 388.23 kg steam per hour at temperature 130 Celsius. And then the come outs, we have three come outs from this evaporator unit. Firstly is M.14 that have contained evaporated water at the flow rate 170 kg per hour at pressure 101 kilopascal. And also for the M.15, the come out is the output is 570.23 kg per hour, that consists sucrose and water at temperature 100 Celsius. And then lastly is M.7 that consists of condensed steam, which is 199.58 kg per hour. That's all. Thank you.
So today I'm going to talk about cash flow and costing of this process design. So this is our total capital costing and operating costing. So the total summary of the capital costing are estimating ISBL using lime factor, which is 3.86. We gain like about 75,000. And OSBL is used by having like 40% of the ISBL. Design and engineering is 20% of ISBL plus with OSBL. Contingency is 10% of ISBL. Add to the OSBL. So like the total fixed cost is the sum of ISBL, OSBL, design and engineering, and contingency. So the estimating with working capital is 50% of the total fixed cost, and the total investment required is the estimating working capital plus with the total fixed cost. So as you can see that we got the total investment required of our design is 1,576,547.18 million. So that is a major cost, and our total fixed capital is 1,037,910. So our operating cost is mainly like 4 million plus minus. So this is our cash flow with our production rate of 4,500 ton per year, and our price per ton is 2,250. So also is like about 10 million. So we'll get our payback of our investments in like the 4th year. So this is our cumulative cash flow. So
my name is Nur Sazwani binti Lutfi. Now I'm going to summarize the project. From this project, we get important information to various sources such as books, journal, website, and reference from the reliable sources. In addition, our end product of this project is sugar that was 570.23 kg per hour, and this reached our objective. So now I'm going to give the recommendation for the future study.
Here is some example of way that can improve our final outcome for the production of sugar from wheat. First of all, we need to improve the equipment to be more effective in the production of sugar so that more sugar is produced at the end of process. Besides, we can use a high quality beet for sugar production so that more fresh and high quality sugar is produced. Finally, we can introduce an economizer group in the steam dryer. If the sugar factory is low in energy consumption, it is difficult to make enough power and dry all pulp. It can be necessary to buy power or install the gas turbine. The power situation can be improved by a combination steam dryer and low temperature dryer.